Everyone, it's Actuary Dude over here, and today we're going to look at another question. This is actually, I think, the last one in this kind of, what would you call it, cash flows area, discounting cash flows, whatever you want to call it. The force of interest delta t is a function of time, and at any time t measured in years is given by that formula there. So derive and simplify as far as possible expressions for v of t, as we've done in every other video, is the present value of a unit sum of money due at time t. Okay, this shouldn't be too difficult because the first part's always relatively easy, as we've known, because that's e to the negative integral of this between time t and 0, and when it's 0, well, that's 0, so in fact I can just about write it all out and say it's 0.03t, because that's the integral of that, minus 0. I'm going to say 0.005t squared, because that's 0.01t squared all divided by 2, which is that. And that is for when t is greater than or equal to 0, which is less than or equal to 9. Now, in order to find the next bit, let's find out what v of 9 is equal to. So in order to do that, we'll just sub it in, and I'll use Excel to do that. Okay, so here we go. Equals, that's negative 0.03 times when t is 9, minus 0.005 times t squared, and 9 squared is 81. So that's what we get, negative 0.675. So that's e to the negative 0.675. Okay, cool. And now we've got to find e to the negative integral of this. In fact, I won't write it there. I'll just write it maybe over here. That's pretty close still. E to the negative 0.06, sorry, that's an integral between time t and time, 9. So there we have it, and that bit's going to be equal, and that's all to multiply by a v of 9. And so that's then going to be e to the negative 0.06t in between t and 9, still again multiplied by v of 9. When we simplify this, it's just going to be e to the negative 0.06t when we sub in t, and it's going to then be minus when you sub in 9, and there's a minus out there, so just putting two minuses together, 0.06 times 9 is going to be 0.54, and multiplied by v of 9. V of 9 is this, so that's minus 0.675. And whatever this simplifies to, 0.54 minus 0.675, so equals 0.54 plus that bit there, minus 0.135. So e to the negative 0.06 t minus 0.135, and that is for when t is greater than 9. T is greater than 9. Okay, so that's the first bit done. So double I has got two parts to it. So part A, calculate the present value of £5,000 due at the end of 15 years. So all we're really doing is saying 5,000 multiplied by v of 15. So that's fairly straightforward. All we've got to do is sub 15 into here, and we'll use Excel to do that. So equals 5,000 multiplied by the exponential of negative 0.06 times 15 minus 0.135 gives us our answer, 1776.13. Okay, so there we go, 1776.13 pounds. Okay, now we can look at part B. Calculate the constant force of interest implied by the transaction in part A. Alright, so let's just write that 1776.13 multiplied by 1 plus some effective interest rate. This is the way I want to do it. There are other ways of doing this. To the power of 15 years, it's going to give us our 5,000. So when we find out what I is equal to, or when we find out what 1 plus I equals to, we know that e to the delta is equal to 1 plus I. So our delta here is going to be ln 1 plus I, which will be equal to, all we've got to do is find the natural log of 1 plus I. So let's just figure this bit out and say is equal to 5,000 divided by that bit there, 1776.13, to the power of, to get rid of that 15, it's 1 over 15, and that gives us 1 plus I, so equals the natural logarithm of 1 plus I, we get 0.069. 0.069 or 6.9% per annum as a constant force of interest. That's delta, force of interest. And now we're up to triple I. Calculate the present value of the payment stream. So a continuous payment stream is received at this rate, 100e to the negative 0.02 t per units between t11 and t15. Okay, I think I got that down. Triple one is equal to, so we're finding the present value is equal to, between it was 15 and 11 of, that was 100e to the negative 0.02 t. I think that was, so let's just have a quick look. Yep, and then we've got to multiply it by our v of t during that time when t is greater than 9 because we're starting at 11. So we're just multiplying by this bit, e to the negative 0.06 t minus 0.135. Alright, let's do that. Multiply e to the negative 0.06 t minus 0.135 dt. Okay, we can take out the 100 and we can also simplify by multiplying the two together, and that's going to give us e to the negative 0.08 t minus 0.135, still dt. And then the integral of this, well, that is itself divided by the derivative of the index, so that's 100 divided by negative 0.08 over there. We can take that out, and then we can say e to the negative 0.08 t minus 0.135 inside the square brackets between 15 and 11, and all we have to do is sub it in, and that's going to give us our value there, our present value, the present value. Okay, equals 100 divided by a negative 0.08 multiplied by the exponential of negative 0.08 times 15 minus 0.135, and the same thing, minus the exponential of so negative 0.08 multiplied by 11 minus 0.135, close two brackets, equals 124.06. 124.06. There we go. Pounds. And that's the answer. So thanks so much for watching, and ask any questions if you have any in the comments area.